Okay, so this is video number 3. Now that we know how to find the least common denominator, now we need to know how to use that information, okay, to form an equivalent rational expression or an equivalent fraction, okay? So, this is actually number 13. This is number 13 on page 247. Okay? And so they give us this rational expression, x squared plus 6 over x squared plus 4x plus 4. And they want us to find out what is the numerator of this equivalent rational expression. So we want to make sure that this rational expression and this numerator, okay, is equivalent in value, okay? It's equivalent in value to this rational expression, okay? So the way we're going to do this is, first of all, we're going to look at this rational expression. I've got x squared plus 6 over x squared plus 4x plus 2. All right? And the first thing we need to do is we need to factor this denominator. Okay? So, let's rewrite this rational expression with a completely factored denominator. All right? So, this gives us x squared plus 6 over, okay, we need to completely factor this denominator. So how do we factor it? We need two numbers that multiplied together equals 4 and added together equals 2. Or, I'm sorry, added together equals 4. And the answer is 2, right? 2 times 2 is 4. 2 plus 2 is 4. So, completely factored is x plus 2 times x plus 2. Okay? So all we did was factor this denominator and rewrote this rational expression. Okay? This rational expression equals this rational expression. It's the same thing. I just factored the denominator. Okay? So now this rational expression equals some numerator over this denominator. Okay? So now we have to find what is the new numerator. Well, in order to find that, the first thing we need to do is find out what is the difference in the two denominators. Okay? What happened to the denominator to change this denominator into this denominator? Well, if I look at the original denominator, I had x plus 2 times x plus 2. In the new denominator over here, okay, which is going to have an equivalent value, the denominator has x plus 2, so that checks, right? I've got one x plus 2. I've got another x plus 2. But what don't I have in the original denominator that I do have in the new denominator? I have an x minus 2 over here. Okay? So what did I have to do to this denominator to get to this denominator? Well, I had to multiply x minus 2 to it. All right? And remember our rules with fractions. Whatever you do to change the original denominator, okay, you have to do the same action to change the new numerator. Okay? This is our original numerator, x squared plus 6. Okay? So whatever I do to the denominator, I have to do the exact same thing to the numerator. All right? And we know that the difference is that the new denominator has an x minus 2 multiplied to it. So if we multiplied x minus 2 to the denominator, I also have to multiply the numerator by x minus 2. Okay? So our new numerator is going to be x squared plus 6 times x minus 2. Does that make sense? So I'll take that question mark out and I'll write my new numerator. X squared plus 6 times x minus 2. All right? So that right here is our new numerator. Write the numerator for each equivalent rational expression. This is our new rational expression that is equivalent to our original rational expression. Okay? And this makes sense because if you just look at this rational expression, you know that the numerator has an x minus 2 and the denominator has an x minus 2. And if you wanted to simplify it, you can just cancel the x minus 2's and what's left? Well, what's left is x squared plus 6 over x plus 2 times x plus 2. Okay? So it makes sense. So, write the numerator for the equivalent rational expression. Well, the new numerator is going to be x squared plus 6 times x minus 2. Okay? Hopefully that makes sense to you. All right? This is just a drill. All it is a drill to remind you that whatever you multiply the denominator by, you have to multiply the numerator by that same factor in order to have an equivalent value rational expression. Okay? So x squared plus 6 over x plus 2 times x plus 2 has the same value, has an equivalent value to x squared plus 6 times x minus 2 over x plus 2 times x plus 2 times x minus 2. Has the same value. Okay? It's a different fraction, but it's the same value. It's the equivalent value. Okay? All right. It's very similar to if I have 5 over 6, okay? And that equals what over 24? Well, in order to change this denominator, 6, to 24, what did we have to do to the denominator to get the new denominator of 24? Well, we had to multiply it by 4, right? So I'm going to multiply the denominator by 4. And whatever I multiply the denominator by, I have to multiply the numerator by. Right? So 6 times 4 equals 24. Well, this question mark now becomes 5 times 4. Well, 5 times 4 equals 20. Okay? So 5/6 has the equivalent value as 20 over 24. And we know that because we can actually simplify 20 over 24 by dividing the numerator and the denominator by 4. Okay, and you simplify it and it comes down to 5 over 6. Okay? Same value, just a different fraction. Okay? It's the same concept. Exact same concept. The only thing that we're doing is we're using polynomials or binomials. Okay? All right, hopefully that helps with that. Okay, that's video number 3. And I'm coming back to you with my final video, which is video number 4. Okay? Hopefully this is helping you guys understand this a little bit more. Okay? All right, I will be back in a minute with video number 4.